Hi everyone, here is Mr. Chen. So today I'm going to talk about puzzle variation. So please be ready for your notebook and your stationery. Again, turn to a new page of your notebook. Write down the date of today, the 5th of February. And the learning target. Partly and partly. Okay, let's get started. So I believe that before the holidays, we have already learned 3 variations. Okay. Okay, we have already learned 3 variations. The first one is direct variation. Direct variation. So I can give you an example. That is, for example, y is equals to kx. Okay, and the second one, that is inverse variation. Inverse variations. So I use a similar example. So y is equals to k over x. And the third one, joint variation. And it may contain more than 2 terms or 2 things. That is, for example, z is equals to kx squared over y. And finally, today we are going to talk about the fourth one, that is puzzle variation. And I can give you an very simple example. For example, y contains 2 parts. And the first part varies directly as x. So we just simply write down kx. Okay, and also the second part will varies directly as x squared. As you can see, now there are 2 parts. So you can directly think of, maybe simply think of, there are 2 parts. So what mathematical signs we should use to separate these 2 parts? And the answer is, we'll use a plus. Also, do you think the 2 k's are the same? The answer is no. So how can we separate or identify these 2k? Is we will use k1 and k2 to identify these 2k's. So this is an example of puzzle variations. And of course, we have to write where k1, k2 doesn't not equals to 0. Then we can set up an equation for puzzle variations. And you can see this is partly, this is the first part, and this is another part. So partly. Okay, then we can refer to the notes. And again, it is very important when we do the math or in this section to set up the first step. We have to set up the equation or the expression. Okay, so please first use a highlight pen to highlight the keywords. Okay, again, as we can see, partly, and partly. So it is very obvious that when we see the word partly, then we should directly or immediately think of we are using partial variations. So I will demonstrate part A and part D for you. Okay, as you can see, P is partly constant for part A, P is partly constant and partly various as Y. Okay, so we know that P is equals to, there must be K1 and K2 for partial variations. The first part is a constant, and the second part is directly various as Y, so K2Y. So you have to remember that partly constant, that means there is nothing else, just K1. And then when we identify the two parts, then we can use a plus to add up the two parts. And then for part D, U contains two parts, partly various directly K1 and K2. Okay, the first part directly various as V square, so K1 V square. And similarly, another part various inversely as the square root of V, not V is square root of V. So we will use a fraction. And then again, plus. Okay, so for part B, C, and E, please use around 1 minute to do it, and I will show you the answer afterwards. Okay, for part B, S is equals to K1 plus K2 over Y cubed. And for part C, W is equals to K1X plus K2X squared. And finally, for part E, W is equals to K1 over the cube of T plus K2 to the cube root of U. So that's the end of the part 1 videos. And the next part, I will demonstrate some examples for you. See you